The correct model here is B. The exposure seconds is equal to 49 minus 0.6 times the year since 1930. The reason I'm doing it as year since 1930 is because on my graphic I'm not given my y-axis here doesn't go to at x equals 0, it goes at x equals 1937. So it's just easier for me to estimate the equation of that line using years since 1937 as my x variable. You can see I'm very close to 50 here, so I'm guessing that that intercept is at about 49, so that's my intercept. How do I get the slope here? Well, slope is rise over run, so we're going to just calculate the change in y over the change in x. So the change in y in this graph, we're going from about, I'm just kind of estimating 49, maybe down to about 10 here. So I'm going to say that's roughly 39. We're going down, so it's negative. X changes from 1937 to 2000, so that's a 63 unit change in x. So that's going to give us a slope of about negative 0.6. So that's where I got the slope here. Just kind of eyeballing this graphic here, which Pearson's correlation coefficient looks the most reasonable? So actually it's D, negative 0.3. You can see that there's an awful lot of scatter around this line. This is really not a high correlation at all. So the correct answer is negative 0.3. It's negative certainly because our line is going down, but negative 0.5 is actually too big here. So negative 0.3 is the correct answer. There is a little bit of correlation, so it's not 0.01 here, but it's very weak, so it's negative 0.3. The correct answer to this is B. Actually, linear regression is probably not totally appropriate here. We have a fairly small sample size, and we're violating probably two of the assumptions of linear regression. So you can see that we have a lot of zeros in terms of the alcohol exposure time in the movies. If you have a lot of zeros like that, if we were to put this in a histogram, you're going to get this kind of huge zeros, and then it's probably going to be a right skewed distribution. It's definitely not going to be normal, and we've got a fairly small sample size here. Also, we're violating homogeneity of variances. You see that there was actually a lot of variance in the movie's alcohol exposure in early years, and then it was kind of less in between, and then there seems to be more at the end. That may just reflect how many movies are captured at each time point, but it does look like there's some difference in the variances there. The correct linear regression equation here is C. It's going to be a dummy-coded regression equation because we have a categorical predictor. So our outcome is log CRP. We're going to have some intercept which will represent the mean in the reference group. And then we're going to have a beta for the infrequent drinkers and a beta for the occasional or regular drinkers. And what does it mean to dummy code? So again, when we dummy code, what we're doing is we're saying we've got a categorical predictor. We want to represent that with two binary variables. So here's my drinking categories. I've got my occasional regular drinkers. I've got my infrequent drinkers. And then I'm making the never drinkers the reference group. That's somewhat arbitrary, but that was the only correct answer I gave you. So you had to use that one as the reference group. Then I'm making two new variables, a binary variable which is you're an infrequent drinker or you're not, and a binary variable which says you're an occasional or regular drinker or you're not. So that means the occasional regular drinkers will be a 1 on that variable, and the other two will be zeros. The infrequent drinkers will get a 1 on the infrequent variable, and the other two will get zeros. And the never group, by default, they're the ones that get a 0 for that infrequent variable and a 0 for that occasional regular category. So they actually their mean will be captured in the intercept. The correct answer here is negative 1.35. Where did I get that from? So I'm going to go to the graphic for the occasional regular drinkers, and I'm looking for the slope for the people without depression. That's the solid line. Well, that line goes from about a positive 0.1 down to about negative 1.25. So what's the slope? Well, the change in y here, it goes down 1.35. X goes from never drinker to occasional drinker. Remember, this is coded as a 0, 1 variable, so the change in x is just going to be 1. So our slope is negative 1.35. It's just the difference in the means between the reference group, the never drinker group, and the occasional regular drinker group. For this question, notice I didn't specify which graph for you to look at. That's because the intercept represents the mean for the never drinkers, and you can see the never drinkers on both graphics. The never drinkers have a mean of 0.1, so the intercept here is going to be positive 0.1, or that's A here. So one of the main conclusions from this picture that we can draw is B. The alcohol drinking seems to be associated with a smaller decrease in inflammation in the depressed group than in the non-depressed group. The non-depressed people seem to get a better benefit from alcohol. There's actually an interaction going on here, and that's what this graphic illustrates. So the correct model here is D. This is a linear regression model that has just a categorical predictor in the model that's been dummy coded. So if you find the 4.4 in our little table here, the outcome is visual reception. We're talking about the unadjusted beta. So the only thing that's in the model is the categorical variable. It's a 3-level categorical variable. You are either exclusively formula fed, partially breastfed, or exclusively or almost exclusively breastfed. So there's 3 categories. So our visual reception scores are outcome. That's going to be equal to some intercept plus the beta for the exclusive breastfeeders plus the beta for the partial breastfeeders. And I'm assuming that and it tells us actually in the table that the reference group is the formula fed group, so that's why those are captured in the intercept. The correct answer here is B. Again, we're talking about this value of 4.4. It's saying that on average, it's a yes/no variable here. You're either exclusively breastfed, and that's being compared to the reference group of exclusively formula fed. So on average, the exclusively breastfed babies score 4.4 points higher in visual reception compared with the formula fed babies. That's what the value of that beta coefficient means. The beta coefficient, the 95% confidence interval here goes from 0.7 to 8.2. It does not cross the null value of 0. Therefore, we know that this is a statistically significant result. So again, the correct answer is B. So the correct answer here is A. Much of the apparent relationship between exclusive breastfeeding and infant cognitive function was actually due to confounding by other variables. And you can see that here in all of these different models and all these different outcomes. You can see, for example, for the visual reception score, it goes from 4.4 down to 2.4 once you've adjusted for these potential confounders. So there's a big drop in the beta, and that's true across all of the different betas that are measuring cognitive function here, not just the visual reception score. The correct answer here is A. Breast milk DHA was treated as a continuous variable. So these beta coefficients represent the change in cognitive score for every 1% increase in DHA. There's actually a clue here in the table, because if you read carefully, you can see it says continuous, and if you read the fine print, it tells you that the units here are per a 1% increase in fatty acid concentration.